Translate and solve. So we're going to use an equation. So in our problems, there's going to be a percent that's given, or we need to find. And then that's going to be over 100 for this equation. Then we're going to go times of, which is equal to, is. So let's break this down, right? So the percent is equal to the percent in the problem, right? And we just put it over 100, so then it goes into a decimal. And then we have the word of. So usually there's this word of, and then it's followed by a number. And so that means we're going to go ahead and multiply that. That's what that means. So we have times of. So we have our percent, which is over 100, times of. And then is means it's going to be equal to all that. Let's put this in perspective. So if we say 30% of 30 of the kids is what? So, right, we have 30%, and then, right, so we put the 30 there, we put of the total students, which is 30, and then that will get us to the actual amount of kids that have the peanut allergy. So that's what all that means. So let's look at some examples to see what this is. Example 1. So during the pandemic, you want to make sure you're below the 50% occupancy. So if the motel has 25 rooms and during the past 30 days, so there's 750 possible bookings because we multiply 25 times 30, which is 750. So the number of nights booked for the room was 250. So what percent is your occupancy rate? So let's go ahead and look at our equation. So if we look at this, what are we trying to find? Well, we're trying to find the percent. So let's see what we have. So we have this of. So that of is going to be like the possible bookings. So the percent over 100 times 750, right? And then the number of nights booked for the rooms was, so, right, just past tense for is 250. So let's go ahead and now go ahead and start solving for this percent, right? So what can we do here, right? So the first thing we can do, so we have 750 times this percent, which sometimes you might see it as 1%, like that. So we're looking for this, that's our essentially our variable, right? So what we can do is take a fraction, and we're going to go ahead and multiply it on both sides. Now, why do we multiply it by 100 over 750? Well, percent times 750 is divided by 100, right? Or we can go 750 times x over 100. So in order to get rid of these two numbers, we can just go ahead and just multiply it by the reciprocal, right? So that'd be 100 and then 750 on the bottom. So this gets rid of it here because that just becomes 1. Gets rid of it here, that just becomes 1. So now what are we left with? So we're looking at, right, what percent is now equal to 250 times 100 over 750. So let's go ahead and start to solve. So we have 250 times 100, right, because we multiply what's on the top, so that's 250, then times 100, divided by 750, and we get 33.33, and it continues on. So we can just go 33.3%. So we could say it's definitely below the 50%. So let's look at another example. Example 2. A retail store owner wants to determine a 30% occupancy for the store. So what is 30% of 48? So what it's saying is that 30% of 48, which is the total amount of people that can be in the store, say if it wasn't during a pandemic or anything else or any kind of event, right? So if there was 48, so what's 30% of 48 is equal to what? So if we look at this, so we have 30% over 100, right? And then times, which is 48, equals what number? So sometimes we can just go like this. You can also do X, but I like to sometimes just do it like that, just because that's how I learned it when I first did these. So if we look at this, we have 30 over 100, so it gets rid of the percent, so now it's a decimal. So we have, let's pull our calculators out. So we have 30 over 100, that becomes 0.3. We're going to multiply that by 48, and we get 14.4. So if the retail store owner wanted to determine the occupancy rate, right, it's 14.4, but let's go ahead and round to the nearest whole number, because this is in terms of people and how many people can be in there. So we're going to round to the nearest whole number. So we look at this 4, notice between 0 to 4. So we round down to the nearest whole number, which would be 14. Example 3. A restaurant owner is wanting to keep their occupancy at 25% and determine that is 30 people. So what is the maximum occupancy of the restaurant? So another way to ask is 30 is 25% of what number? So let's go ahead and plug all this in, right? So we have percent, right, over 100 times of equals is. So if we have our percent, we can go ahead and plug that in. So it's 25 over 100. So times, which is what number? So that's what we're looking for, right? So this is what we're looking for. And is 30. So whatever this number is, it's multiplied by the 25 over 100 and gets us to a really small number, right? So it's like 1/4 of what the maximum occupancy is, right? So that's what we're looking for. So let's go ahead and solve. So if we're looking to get what number, all we need to do is go ahead and multiply by 100 over 25 on both sides. This gets rid of it on this side, so this just becomes 1. And then we're left with 30 times 100 over 25. So how do we solve for that? Right, we just go 30, then times 100, divided by 25, and we get 120. So that's the maximum occupancy of the restaurant.